Chapter 9, Lesson 5, Logarithmic Notations. So the first thing we're going to do is change from log equations to exponential functions. So what you have to remember is that logs and exponentials are opposites. So just like adding and subtracting, multiplying and dividing, square rooting, and squaring. So whenever you have a log equation, and we call it log base b of x equals y, so I'm right here, it can be rewritten as b to the y power equals x. So for this first example, if I have the log base 5 of 25 equals 2, I could say that 5 squared equals 25. So this one, log base 6 of 1/6 equals -1, and they want me to rewrite it as an exponent. So I say 6 to the -1 is 1/6. And this one, log base 2 of the square root of 2 equals 1/2. 2 to the 1/2 equals the square root of 2. Log base 3 of 81 equals 4. 3 to the 4 equals 81. Now we're going to be changing exponents back into logs. So changing 9 to the 3rd equals 729. We say log base 9 of 729 equals 3. So this one I would say log base 6 of 1/36 equals -2. Log base 4 of 64 equals 3. Log base 5 of the cube root of 5 equals 1/3. So this number here stays on the side, and then these two switch is what we're doing for these. So in order to solve log equations, because we can't do them in our calculator, we're going to change them into exponents and then use our roots page, which hopefully you have your roots page with you, and solve. So this one, if I change into exponential, it'd be 4 to the x equals 1/4. And how would I get a 1/4 fraction? Well, I'd have to take 4 to the -1 power. So the answer for x is -1. When I change the next one, it says 5 to the 3rd equals x. And so this one, I just put 5 to the 3rd in my calculator, and an x is 125. This one is x to the 1st equals 25. Well, what to the 1st would stay as 25 if x was 25? And the last one, 3 to the x equals 1. Well, the only way to get something to a power to equal 1 is if that power is 0. Okay, we're going to use, since logs and exponents are opposites, we're going to use exponents to graph log functions. So we're going to first write the equations in exponent notation, then use a t-chart for the values. Now, normally when we do this, we would put the values for x, but since we're doing inverse or opposite, we're going to put the values this time in for y after we change it to exponential. So this one, if I have log base 2 to the x equals y, that's going to become 2 to the y equals x. So for the first one, I'm going to do 2 to the -1st, which is 1/2. And this is supposed to be like a t-chart, like this. Okay, next, 2 to the 0 equals 1, and 2 to the 1st equals 2. So I have 1/2, -1, 1, 0, and 2, 1. So this one, first I'm going to change this into y equals. So I have 1/3 to the y equals x. And since I'm doing the inverse, I'm going to put my values over here. So I have 1/3 to the -1, which is 3, 1/3 to the 0, which is 1, and 1/3 to the 1, which is 1/3. So 3, -1, 1, 0, and 1/3, 1. This one would become 8 to the y equals x. 8 to the negative 1 is 1/8. 8 to the 0 is 1. 8 to the 1 is 8. So I have 1/8 negative 1, 1 comma 0, and 8 comma 1.